Copyright in these lectures is either owned by the ANU or a third party who has licensed the ANU to use it. Students may use the recording for personal study only. No lecture may be communicated online, copied or shared without the prior permission of the ANU.
All right. Welcome back, everyone. Welcome back, everyone. Today we're going to be talking about, so today is our fourth lecture. We're going to be talking about total surplus. We're going to talk a little bit about government intervention into nice-looking markets and why we don't necessarily want to have government intervention when our markets are behaving nicely. And then towards the end, we'll talk about externalities as well, which is, one of the types of occasions when we do want to have government intervention in our market, when government intervention can cause increases in total welfare or in total surplus. So as I say, total surplus, net weight loss. We'll talk about some government interventions, notably the simple ones, price ceilings and floors, and government taxation and subsidies. And then towards the end, we'll talk about externalities. A quick note on taxes and subsidies, and I'll say this again as we come to it. We will be doing taxes and subsidies differently than how it's done in the textbook. The textbook does it as a shift in cost curves, and we will not be doing it that way because we'll be using a tax and subsidy wedge method, so what's called tax wedge method, which is much nicer for welfare analysis. And since we're going to be interested mostly in welfare analysis, that's what we're going to be working with for the most part. But I'll talk more about that as I come to it. A quick mistake from last week. I made an offhand comment last week when I said that the market equilibrium is the only Pareto efficient outcome, and that was not true. There is more than one outcome that is Pareto efficient because price has no role in Pareto efficiency, which is to say price, and we'll talk more about this today as we talk about particularly dead weight loss. Price is just a transfer, and so the particular price we have isn't going to affect the amount of total surplus that we have. And so there's going to be more than one outcome that is Pareto efficient, as long as any outcome, in particular any outcome where the quantity is the market equilibrium quantity is going to be Pareto efficient, but it's not necessarily going to be what I'm going to call incentive compatible. The technical term is incentive compatible. I'm not going to go into this in detail, but basically any outcome where the quantity is the market equilibrium quantity, and for any given price level, that's going to be Pareto efficient, but that's not going to be stable. It's not going to be incentive compatible. Each agent is not going to be doing the best for themselves, which is the case for the market outcome as well. So I made a small mistake. I went a bit too far last week, and we'll talk more about some of these things as we go through. Yep. Elasticity. Good point on elasticity. Thank you. Because elasticity is kind of a little bit of a side issue for the entire course. It's important, but it's slightly to the side. I'm going to be making a lecture recording for that tomorrow and post that up, and that'll be posted up on Wattle tomorrow as a video that you can watch at home. I anticipate it being about a 45-minute video that you can watch at home. Basically just me going through the lecture slides and talking about why elasticity is nice compared to sensitivity, why it is some of the weaknesses, particularly in terms of interpretability to a certain extent, but also calculation is a little bit fiddlier. The fact that it doesn't work nicely with linear demand and supply curves, which is most of what we work with. So there are some issues with it. I'll talk about those in that video recording, but mostly it's nice. But as I say, I'll talk about it in this video recording that I'll be posting, that I intend to post tomorrow. Otherwise, any questions on this mistake or on what we've done so far, or anything I've said so far today, or issues like that? Lovely. So I want to talk a little bit about the assessments because there's now assessments available. So the problem set was released on Wattle on Tuesday afternoon. This needs to be submitted on Wattle by 11:59 p.m. on next Tuesday. So you have a week to do it. You had a week to do it. Now you have 5 days to do it. Late submissions are just not accepted. So if it's after 11:59 p.m., then it's after 11:59 p.m. and that's it. You can handwrite your solutions. That's okay. Handwrite and then scan and then submit as a PDF. That's fine. You can type your solutions. That's fantastic. In many cases, because you'll be expected to do things like draw graphs, and that takes a lot of time to do in any kind of on-computer software, or it takes longer than would be ideal in most kinds of software. I'm very, very happy for you to type out the written part of your solution, to draw the graph part of your solution or the mathematics part of your solutions, and then to just scan in the relevant sections and paste them in as part of a Word doc or whatever it is that you're using. I'm very, very happy with that as options. Please do submit as a PDF. It's not a big deal, but I would prefer if it's submitted as PDF. When you submit this file, to make our lives a lot easier for marking, there's all these different problem set options based on your student number. If you could please submit to the box assigned to your student number, will make our lives a lot easier for marking. It doesn't affect you guys at all, it just makes our lives easier if you can submit to the correct problem set box depending on your student number. Otherwise, so the problem set is what? Three true, false, uncertains and 2 longer responses with multiple parts in them. You can have a look online. Any questions at this time? Questions, concerns? Yes. No. You have until now until next Tuesday. Until Tuesday at 11:59 p.m. when it must be submitted by then. Has anyone not used Turnitin before? Who has not used Turnitin before? Who has used Turnitin before? Glorious, then you're all fine. If you've not used it before and didn't put your hand up, it's okay. I'm just saying it can be fiddly, especially your first time. So just, don't go in at 11:50. Expect to submit it on time, because if it's late, it's not accepted. So make sure you go. If it's your first time, particularly, you want to practice and so forth. Yes. The question was, if it's a definition-related question, should you reference the definition? Should you make references? For this problem set, you are not expected to have any references. That's a good question. I like that question now I like that question. The question was, should we paraphrase or can we directly copy what's in lecture slides? And the answer is, if you directly copy what's written in lecture slides, you've committed plagiarism. Right? So don't do that. Right? You must paraphrase. Everything is in your own words. Right? If you're asked to explain, what's a decent example? If you're asked to explain what a market equilibrium is, I want you to tell me what you think a market equilibrium is. I don't want you to tell me what I think a market equilibrium is. So yes, if you can't copy directly.
Are we able to paraphrase referencing other journals?
Yes, so the question is, can we reference other journals? If you reference outside the course, then it's good to say where you got the information from. But this is a fairly small problem set. For the personal project, that's very different. This is a fairly small problem set. You're not really expected to have to go significantly outside the course to get more material. You should be able to answer all the questions purely from material that we've covered in this course. So yes, you can go outside, particularly for examples, but you shouldn't feel like you have to go outside the course. Other questions? Okay. Now this is where it's going to get frustrating for me, because even though I've said it here and I've said it in the discussion forum and I'm saying it in lecture, I'm still going to get questions about it afterwards, which is all this stuff here. So a brief outline of how we think when marking the true, particularly the true, false, uncertain questions. So these are going to appear in the problem sets, in both problem sets and in both exams, these true, false, uncertain questions, and they've been in your tutorials. And hopefully your tutor's already been through and talked about how we would think about how we think when we're marking these. The first thing to note is there's a breakdown of marks between the marks assigned to whether you say true, false, or uncertain, and your explanation of why you think the answer is true, false, or uncertain. And that breakdown is 0 marks for saying true, false, or uncertain, and 10 marks for your explanation. All of the marks for these questions is assigned to the explanation for why you think this thing is true, false, or uncertain. The reason for that is that for most of the questions, more than one of those is true. More than one of those is acceptable. For most questions, true is acceptable, or uncertain is acceptable, or false and uncertain are acceptable. And sometimes true, false, and uncertain are all acceptable, depending on how you interpret the question. depending on where you put the emphasis on the question, which is why all of the marks are for the explain part. And the same explanation can usually be given for an answer of true or an answer of uncertain, or an answer of uncertain and an answer of false can often have basically the same explanations. So I'm just making it clear that and what this means as well is if the only thing you write is true and then nothing else, you will get 0 marks. Right? That is treated as a question that has not been given an answer to. We treat the answer of true as 0 marks. I'm saying it clearly now, as clearly as I possibly can, because then I can come back to this recording later and say, look, this is where I said it in the lecture, and on here. The other thing to note for these questions is that a standard correct answer would be getting about 8 out of 10. That is to say, if you produce an answer that is good, that covers the point, covers all the major points, and does so in a reasonable way, you would be expecting to get 8 out of 10. Getting 9 out of 10 or 10 out of 10 is for extra stuff. So you receive 9 if you have a particularly well-reasoned or well-explained answer, if you talk about not just the major points but also the minor points, you talk about not just the major and minor points but some extra little bits and pieces here and there, gets you to 9 out of 10. 10 out of 10 is for answers that are truly exceptional, right? This class has 520 students, I think, in it, something like that, 530, I think, students. We would be expecting, for each question, maybe 10 to 20 students to be getting 10 out of 10, right? It's for those really, really good responses. Now, keeping in mind, 8 out of 10 is still a high distinction, right? 8 out of 10 means you did a high distinction level piece of work. 9 out of 10 means you did a better than high distinction, a really good high distinction. 10 out of 10 means you did a fantastic, phenomenal piece of work. So you should not, if you get your response back and you have 8 out of 10, it's not that you've done something wrong, it's that other people gave better explanations, gave more well-reasoned, better explained answers, better examples, did it better. It's not that yours was wrong, it's that it could have been improved. Yes, any question? Yes. Yes. I can certainly give example 10 out of 10s. I don't actually have example 8 out of 10s in my storage. I meant to post those up already, and I will do that after the lecture. I'll post up some example optimal solutions, example ideal solutions. I should say as well, for these questions, these true, false, or uncertain questions, because you can talk on each of these for like 5 pages if you really, really desperately wanted to, we'd be expecting these to be about 1 written page, so about 150, 200 words. And then if there are graphs, you would have less words because there are graphs, generally speaking. So if you're feeling like you've written 1 sentence, that's enough. That's not enough, right? We expect more explanation than a single sentence. If you feel like you've written 6 pages, then you've written too much. Within reasons, and again, I'll post some examples of these to demonstrate this to a certain extent. Questions, concerns? Okay, so quick notes then on proper academic conduct. I hate having to talk about this, but I feel like I do have to talk about this. So the university's policy on appropriate academic conduct, which is our plagiarism issues, is really super detailed. There's an official policy document. It's linked to in the course outline, which is super detailed. But because it is so detailed, because there's so much information, it can be a little difficult to decipher exactly where the line between acceptable and unacceptable academic conduct lies, because there's so much information. So I want to give you a tiny bit of information to really hopefully clarify that line very carefully. And that line is the acceptable working together, if you like, because you will work. You're expected to work together to a certain extent and expected to work on your own to a certain extent. The working together that's acceptable is discussing in words, as it says out here. Can you read this? Is this readable? In the back? Yes. Acceptable is discussing in words the material in the assignment and how you might go about approaching the solutions, right? You get together, before you start the assignment, you get together, a group of 3 or 4 of you, and you say, we've all read through it. I think question 2 is really hard and have no idea how to even approach question 2. And Bob over here says, yes, well, I reckon in question 2, the way you should approach this is probably to do such and such and such and such. And you go, oh yeah, that's great. And Bob goes, I think question 3 is really hard. And you explain how you might go about doing question 3. And then you go away and you do the questions yourself, right? The unacceptable things are taking written notes when you have those kinds of discussions. That's going to lead to plagiarism. Unacceptable things are having someone else's written work, particularly completed written work, in front of you and then trying to write your own solutions by paraphrasing them. That's going to lead to academic misconduct. Obviously, copying someone else's work is actually just straight up plagiarism. Right? That just is plagiarism. These other steps here, copying someone's work is just plagiarism. These other steps, taking written notes, having someone else's written work in front of you, these are not in and of themselves academic misconduct, but they will lead to, well, actually the second one is. The first one's not. The second one is academic misconduct, but they will lead to academic misconduct, right? We know what an assignment, we've marked lots of assignments. We know what an assignment looks like when it's been changed because you've had someone else's assignment in front of you and you're not copying it, you're paraphrasing, right? We know what that looks like, and that's academic, and it is academic. It is considered by the university to be academic misconduct. So just make it very clear where ANU draws that line, where I will be drawing that line for this assignment. For other assignments, the line is different, right? For take-home exams, the line is very different. For personal projects, the line will be a little bit different. But for this kind of assignment, this is where the line gets drawn. Any questions on anything to do with problem set 1? It's all clear? It's all okay? Excellent. In that case, we can do content. So, as I say, content today, the first part of today, I'm going to talk a bit about total surplus and about dead weight loss. So total surplus is hopefully at this point really straightforward. In week 2, for consumers, we talked about consumer surplus, which you'll hopefully recall is this gap between the marginal benefit curve and the price they actually pay for the good up to the amount that they actually consume. Because for each unit of consumption, the net benefit, if you like, the benefit after cost, is that gap between marginal benefit and cost, and price, I should say, and price. And we just add up all of those gaps. For producers, we have the same idea of producer surplus, which is this extra benefit that producers receive from selling, taking into account cost of production. So it's that gap between the marginal cost curve and the price that they receive. Because for each good, they pay the marginal cost and they receive the price. And we add up for each good. So then we can talk about total surplus. So the total surplus is typically the sum of consumer surplus and producer surplus. We just add these two things up. If there's government intervention, we'll throw in any government surplus, so any changes in government surplus. When the government taxes people, the government gets revenue, and the government likes getting revenue. When the government gives subsidies, the government pays out money, the government doesn't like doing. So that's going to be included in total surplus. When we talk about externalities, the effect on others is going to be included in total surplus. Total surplus is, net benefit to everyone that matters. There's a really subtle point built into total surplus here, which is that it really implies the fact that we care at all about total surplus, that we care at all about just adding up consumer surplus and producer surplus, implies that we really care equally about these two things, that we care equally about consumer surplus and producer surplus, which is in some sense a little bit strange. Right? If I'm a benevolent dictator and I'm trying to design my economy, why would I care equally about this group of people, consumers, to this group of people, producers? And there's a few reasons why we do that. One reason is built into our modelling, which is to say that in most modelling, consumers and producers are the same people. They're just sometimes we're consuming. When I eat a banana, I'm a consumer. When I give a lecture, I'm a producer. So they're the same people. So it all works out in the wash. The other much better argument, I find, is that total surplus is really the net amount of extra benefit that's sloshing around in our economy. And how that extra benefit gets assigned to people is largely up to the decision of the central government. And so if we can maximize total surplus, then we can later on decide how to structure our market, how to structure transfers, lump sum transfers, to just move money around between people. Right? If we're looking at some market and consumers have masses of and we as the government actually really want to give lots of surplus to consumers, but in this particular market consumers aren't getting much surplus, we can just do a lump sum tax on producers, take a big pile of surplus from producers and throw it onto consumers as a lump sum. And so we can move surplus around. As the benevolent dictator, we can move surplus around pretty easily by using lump sum transfers. And so for that reason, we really do mostly care about total surplus, about the sum of consumer surplus and producer surplus. is a useful concept. Any concerns, questions at this time? Yes. The difference between these makes up profit because, I mean, it doesn't. Hopefully, with more slides, your question will become clear. It will become clearer why it's not why the question. Yeah, I'm not going to answer the question at this point, but it'll become clearer as we go through. Okay, so total surplus in a market is the benefit gained by consumers and producers from trade in that market. And graphically, this is pretty straightforward. We have a market, we have some quantity, we have some price, we have some marginal benefit curve that I do want to link up. We have some marginal cost curve or supply curve, if you like. We can talk about the consumer surplus. So in equilibrium, I should say it like this. In our nice equilibrium market outcome, we live here, at this point here, in the nice market equilibrium outcome. Right. Q star, P star. And if that's the case, then consumer surplus is going to be this region in here. Up here we have our consumer surplus, this gap between marginal benefit and price. Down here we have producer surplus, right, this gap between price and marginal cost. And so the entire region, which I don't have enough colours for, but the entire region here, just the sum of these two things, is going to be total surplus. It's just we just add these things up. If we were if we were not in equilibrium, that's also fine. I know I'm going off the page. I'll fix it in a second. If we were not in equilibrium, so we have a marginal cost or supply curve, a marginal benefit or demand curve. If our economy lived at this point here for some reason, right, for whatever reason, if our economy lives here, so that we trade this Q0 amount at price P0, then we can talk about the consumer and producer surplus still, right? We still talk about consumer producer surplus. We have this region up here is consumer surplus, this region down here is producer surplus. And so the sum of those two is going to be, right, the sum of those two regions is going to be total surplus. Total surplus. Which is the amount of net benefit from trade sloshing around in this market. Questions, concerns, issues? Okay. And so we can talk about example total surpluses. So we take our Apple market from last time where we have prices, we have quantity demanded, quantity supplied, and we can talk about the market conditions from last time. Let's talk about what the total surplus would be under various circumstances. So assuming, first off, this is going to be important, assuming that goods are only bought and sold if there's someone to buy the good and someone to sell the good. It's not an uncommon assumption, but it is something that that's going to be important for our discussion of this question. Quantity, we have price, this is apples. And we have when the price is $2, the supply curve has zero quantity supplied. When the price is $6, we have nothing demanded, and that this is 4, 2. And we can talk about the consumer, producer, and total surplus for various price points. So, and again, assuming goods are only bought and sold if there's someone to buy and someone to sell, we can look at the consumer surplus for varying price points. At a price of $2, there's no surplus because there's no trade. So at a price of $2, at this very, very low price, consumers would be super good, would be incredibly well off if they could buy, but there's no one to sell. No one wants to sell goods at $2 per kilo. So there's therefore zero consumer surplus, zero producer surplus. We can talk about a price of $3. Now, at a price of $3, there is some trade that goes on, right? Quantity demanded, quantity supplied is only 1. Quantity demanded is 3. That means we actually only sell 1 unit of the good. There's an actual shortage in our market because demand exceeds supply, because the price is very low. So 1 tonne actually gets traded in the market. I shouldn't say amount traded, I should say amount traded rather than amount sold. Amount traded is 100,000 tonnes of apples. Consumer surplus, if we live here at this point, this graph's going to get real messy real fast. Consumer surplus is this region here, because it is the gap between marginal benefit and price up to amount actually consumed. And if you sit down, you can find pretty quickly that this is 2.5, size 2.5. Producer surplus is going to be this little triangle down here, which is size 1/2, and so total surplus is 3. But we can do better. We can have more, so the total surplus is this region here, this little trapezoid or trapezium here. And we can do better. We can talk about when the price is $4. And when the price is $4, we do actually trade at the market equilibrium. We get 200,000 tonnes of apples traded, and we get consumer surplus of this big triangle here, producer surplus of this big triangle here, and each of producers and consumers get surplus of 2, and total surplus is 4, and this gives us the highest total surplus. And you can go through the other numbers yourself. This gives us the highest total surplus. You'll notice, however, consumers are worse off at a price of $4 than $3. If there was some reason why the government wanted to care about consumers, then there might be some reason they would try and lock prices at $3, right, if they cared more about consumers than producers. Similarly, if they cared more about producers than consumers, they might lock prices at the price at $5, right, because that gives producers more benefit than they do in the equilibrium outcome. The equilibrium outcome doesn't mean everyone gets the most. It means there's the most in total. And that's pretty standard. Do I have anything here? Yeah. Any questions? Questions, concerns, issues? The crux here is that total surplus is maximized when the quantity is given by this intersection of supply and demand. That's what we end up with, giving maximized total surplus. And the reason why we maximize total surplus in that location is... Whoa, I've gone back. No, I don't have to worry. The other thing I want to say, which comes back to this point here, this nice graph here, is that total surplus does not depend directly on price. The price of the good does not it will indirectly affect, right? It does indirectly affect, but the price of the good does not, the total surplus does not directly depend on price. And that's because when I buy something, right, the benefit to society is the marginal benefit that I get from consuming the good. The marginal cost to society is the cost paid by the producer in producing the good, the marginal cost paid by the producer to produce the good. The society as a whole doesn't care about the money that I give, the physical piece of paper that I give from myself to the producer. Right? That facilitates trade. It's really important, and it's really important for incentive compatibility issues, but it doesn't affect surplus. Right? Because when I pay for something, I become worse off by exactly the amount of money that I've paid, and the person who I'm paying becomes better off by exactly the amount of money that I've paid. And so surplus in the economy hasn't changed because of that transfer of money. So the price, whether that transfer of money is a small amount of money or a large amount of money, isn't going to make any difference. And we can see that on our graph here, hopefully pretty straightforwardly. The fact that I chose this price, P0, as the price makes no difference in terms of the total surplus that's available in this market, that's available here. The Q0 makes a difference, quantity makes a difference, but the price doesn't. If I'd chosen this price down here instead, and the same quantity, right, if I was consuming at price P1 and amount Q0, there's more consumer surplus and less producer surplus, obviously, because the price is lower compared to P0, but total surplus is the same in each case. Right? It's still this trapezium of total surplus. Total surplus only depends on marginal benefit and marginal cost curves and the quantity traded in the market. It doesn't directly depend on price. Now, it will indirectly depend on price. Right? It does indirectly depend on price once we start having these assumptions like goods are only bought and sold if there's someone to buy and someone to sell. That's going to cause us to have, that's going to cause prices, that's going to be the mechanism by which prices affect total surplus. I'm just trying to emphasize they don't directly affect total surplus. They only indirectly affect total surplus because because prices change the amount of quantity traded, and quantity traded affects surplus. Right? Here, the surplus, you'll notice, depends on quantity traded. It doesn't really depend on price, right? Price of 3 and price of 5 both have 1 unit traded. That 1 unit traded is what leads to a total surplus of 3. Right? The price doesn't actually matter at all for the total surplus once we know how much is traded in the market. Okay, questions? Any questions, concerns, problems? Okay, in that case we can talk about deadweight loss. So, when the quantity produced and consumed in the market is different, so as we said, the total surplus is maximised when quantity is given by this intersection of supply and demand at the equilibrium quantity. When the quantity produced is different from that equilibrium quantity, then necessarily the total surplus will then be less, right, than the maximum total surplus. There's some maximum ideal total surplus, and then there's any amount of realised total surplus that might be different because we have different amounts traded in the market. So the gap between the maximised total surplus and the realised total surplus we call deadweight loss. Deadweight loss is the term we use for that gap between the maximised total surplus and the realised total surplus. We call it deadweight loss because, so this is pushing English language a little bit, but it's called deadweight loss because it's the surplus that could have existed, right? There could have been this surplus in the market, but instead there just isn't, right? There's just no such surplus in this market. Going back to looking at our apples example, if we trade 1 unit of the good in our market, then we get this much total surplus, right? That gap between marginal benefit and marginal cost to society. If we'd traded 2 units, we would have also gotten this little triangle here, right? We would have also gotten this section here would also have been additional total surplus we could have had, but which we don't get. And so we call that region that we could have had, but we don't get, we call that deadweight loss. Because it's just an unnecessary and pointless loss to society. Society could have been better off by exactly this amount, and then not because we didn't trade enough. So deadweight loss from a non-equilibrium outcome in a market is the difference between total surplus in the non-equilibrium outcome and total surplus that would have been achieved in the equilibrium outcome. Graphically, the way we work this out is we work out the equilibrium total surplus, right? We draw equilibrium total surplus. We draw the realised total surplus. So this is the realised total surplus for quantity consumed of 1. And we just look at the gap between those two things, between the realised total surplus and the maximised total surplus, is called our deadweight loss. Questions? Questions about deadweight loss. Obviously, we want to argue deadweight loss is a bad thing, which as a societal planner, we want to avoid deadweight loss wherever possible, because it's just, again, surplus that we could have had, but don't. Question? Any questions at this time? Questions, concerns? Sure. Yes, the answer basically is yes. So the question was, in our nice market, where we let our market, in our nice market we've talked about so far, these nice market equilibriums with a demand curve and a supply curve, if we let the market do its thing and reach equilibrium, we would not have deadweight loss, because the equilibrium outcome maximises total surplus. Not so much. After shocks in the market, so if there's a demand shock, demand gets pushed out, we would expect the market to really very quickly realign to the new equilibrium. And so you'd see a change in total surplus between the pre-market, between the pre-shock market and the post-shock market, but you wouldn't talk about deadweight loss necessarily. You would just say there's been a change. So to be really super clear, if we have our initial market, demand, supply, and then we increase demand, so this is the same supply curve. Right, in this market here, we have total surplus. We have maximized total surplus. Right? We would expect the market to reach equilibrium, to live here. We would expect this to be total surplus in this market. Comparatively, in this market here, in this market after the shock happens, we would expect the market to pretty quickly reach the new equilibrium, and we would then have a larger quantity of total surplus. But we wouldn't talk about deadweight loss. Deadweight loss is sort of a gap when we, in a particular given market for a particular given marginal benefit and marginal cost curve, if you're moving around the demand and supply curves, then you're going to change the amount of, the maximized amount of total surplus and also the realized amount of total surplus pretty quickly because you reach new equilibrium. Okay, questions otherwise? Okay, let's talk about some properties of these things. The first property to note is that deadweight loss exists both from underproduction, which we've been talking about mostly here, but also from overproduction. If we produce too much, we also end up with deadweight loss. There's a nice graphical argument for why this is the case. Well, a quick graphical argument for why this is the case. Nope. If we produce this quantity, this is the quantity at which marginal benefit is the same as marginal cost. For each additional unit that we produce past that, the marginal cost to society exceeds the marginal benefit to society. Right? So this is a bad idea because the marginal cost exceeds the marginal benefit. When I produce this next good, to society makes this much loss. When I produce the next good after that, society makes this much loss. Next good after that, next after that. And so as we produce more goods, we're just getting more and more additional loss piling up in our society. And the type of loss that is deadweight loss. So we have deadweight loss both from underconsumption, as we've already talked about, but also from overconsumption. And if we have too much trade, we also have deadweight loss in our society. As I've been really harping on about, deadweight loss does not depend directly on prices. It only depends on quantity traded, because prices are just a transfer between agents within the economy. But it will depend indirectly on prices, because prices affect what we choose to trade, how much we choose to trade. In particular, if the price is really low, then there's going to be very little supply. If the price is very high, there's going to be very little demand, or very little quantity demanded and quantity supplied, I should say. And so because of those incentive compatibility constraints, prices can affect total surplus through that mechanism, but they don't affect it directly. The impact of this, the big impact of this, is if I can work out what the quantity traded is, then I can work out total surplus. And it's often, especially when we talk about externalities and Pigouvian taxation, it's easy to work out quantity traded. It's really hard to work out anything else. It's easy to work out quantity traded. It's hard to work out consumer surplus and producer surplus and where government taxation sits and all those sorts of things. But total surplus is relatively straightforward because we can find quantity traded pretty quickly. Okay, any questions about deadweight loss? Deadweight loss and total surplus. And now we're going to see some government interventions, and those government interventions are going to cause deadweight loss in our nice toy market that we have here. Concerns? Okay, government intervention. So the simplest forms of government intervention that are not used all that much, that used to be everywhere, but are not that prevalent anymore, are price ceilings and price floors. You see them a little bit, but they've fallen really quite far out of fashion, these price ceilings and price floors. So a price ceiling is a government-mandated maximum on the price of some good. The government steps in and the government says, if you're selling apples, you cannot sell apples for more than $4 a kilo, right? Or they step in and, perhaps more realistically, they step into the electricity market and they say, in this market, you cannot sell electricity to consumers for more than $16 per kilowatt hour. Right? That's the amount you can sell electricity for. You are not allowed to sell for more than that. And we can talk about what happens to the economy when you make those kinds of price ceilings. We want to make this is a frustrating thing graphically, which is that a price ceiling is binding when the ceiling is below the equilibrium price, which is to say, if we go to our example if I go to the example I just used for power, if the market wants to sell power at 10 cents per kilowatt hour, that's the equilibrium outcome, and the government steps in and says you can't sell for more than 16 cents per kilowatt hour, then it makes no difference. Then they've put in this price ceiling. It's there. It is a price ceiling, but it's doing nothing, right? Because no one's trying to sell for more than 16 cents per kilowatt hour anyway. So who cares that there's a price ceiling in place? What this means is that a price ceiling is binding when the ceiling is below the equilibrium price. The reason why this is frustrating from a graphical perspective is it means if you draw this thing and draw quantity and price, and we have demand and we have supply, then a binding price ceiling, a price ceiling that's actually doing something, is going to be below the equilibrium price. So a price ceiling that's doing something is going to be down here somewhere. Right? This is where our price ceilings live. Our binding price ceilings live below the equilibrium price. I find this frustrating, at least, because ceilings should be above, right? But graphically, price ceilings fit below equilibrium price. Price floors are the same thing. Price floors are the same thing, but they're a government-mandated minimum on the amount you can sell, on the price you can charge. So this is something like if you're what's a good example of a price floor? Obviously, minimum wages are the most typical price floor. And we use minimum wages everywhere, right? They're a thing in the Australian economy. We have a minimum wage, which covers everyone living in the country, living and working in the country. So if you're living in Australia and working in Australia, you are covered by minimum wage laws and should be receiving at least minimum wage for whatever it is if you're working outside the uni, so you know. It's not citizen-based, it's anyone here. It's covered by minimum wages. So we have and these are price floors. This is where the government steps in and says you can't hire people for less than $20 per hour. I think the current one's about $18.50 is the lowest minimum wage for adult workers that we have in Australia. So you can't pay anyone less than $18 per hour. You're not allowed to pay anyone less than $18 per hour. And this is a standard price floor. So for floors, and again, this is where graphically this is slightly frustrating, because a binding price floor is only binding if people want to pay a price lower than the floor. So a binding price floor actually sits up here somewhere. A binding price floor sits above the equilibrium price. So as I say, it's binding when the floor is above the equilibrium price. Both of these things are distortions in our market. That's not necessarily a good thing or a bad thing, but both price ceilings and price floors are distortions are considered to be distortions in the market. And so we can talk about what effect this has on surpluses, what effect price floor and price ceiling can have on surplus for consumers, surplus for producers, and also indeed total surplus. Ignoring other concerns, right? Ignoring other concerns. And so we can go through. First off, I guess, any questions, concerns about price floors and price ceilings? So when we talk about introducing a price ceiling, let's talk about price ceilings for producers first. If I introduce a binding price ceiling, so this sort of thing, this sort of object here, my producers are definitely worse off. Because if I talk about what happens in the market moves from trading at point A, right, at the intersection of demand and supply. The government steps in and says you can't charge more than this ceiling price, right? And so that's going to be the new price that actually does get charged because it's a binding price ceiling. And at this price ceiling, we're going to live at point B because at this price ceiling, this is the maximum amount suppliers want to supply. At this price, there's obviously lots of other people who have demand, right? There's lots of excess demand, so there is going to be a shortage in this market. There's excess demand. Demand exceeds supply quantity demanded exceeds quantity supplied at this price. But we're bound by the fact that you can only buy stuff if there's someone who wants to sell it to you. So the market will actually live at B. So if you look at producer surplus, producers are definitely worse off. Why are producers worse off? So, what we observe is we observe from A to B, we see that the price falls, right? The price falls, and also the quantity traded falls. Price and quantity both fall in this market when we introduce a price ceiling. And so we can talk about producers. Let's talk about producer surplus. For producer surplus, they receive a lower price for the goods that they sell, which makes them worse off, and they sell less goods, which makes them even worse off. So producers just get totally screwed by price ceilings because they sell less, and they sell at a lower price. So they get completely screwed. They're very deeply, deeply unhappy with price ceilings. Consumers are not quite so bad because consumers say, well, we're trading less, which is bad, but we're being charged a lower price. So this might be good, but it might be bad. And it depends on the price ceiling, it depends on the particular price ceiling. And we can kind of see that way, way back up here with our apples, is that if we introduce a price ceiling of $3 per kilo, consumers become better off. Right? Because the lower price in equilibrium makes them better off, the lower quantity makes them worse off, but the price effect dominates the quantity effect. So our consumers here become better off. If we introduced a price ceiling of $2, our consumers become worse off because the quantity effect dominates the price effect. So we have two distinct effects going on here. So consumer surplus, maybe it'll go up, but maybe it'll go down. We like the fact that prices are lower. We don't like the fact that we're being charged less. What we can say, though, is that total surplus will definitely decrease. Whatever else will happen, total surplus will definitely decrease. Why? Because we're consuming or we're trading at a smaller quantity than the equilibrium quantity. Instead of trading at this nice Q star, we're now trading at this QC, this ceiling-based quantity. And so our total surplus is going to fall to this region here, which means we get deadweight loss, right? Where will the deadweight loss be? If I had this diagram, can anyone point out for me, anyone indicate where the deadweight loss might be? Yep. Yep, perfect. That little triangle, this little triangle here, just to the left of A, because there's a total surplus that we could have had, but we don't because of this price ceiling, right? Which could have had, but we don't because of the price ceiling. Not everyone could have been better off, but we could have traded more and increased the amount of surplus available in our economy. And we can do the same thing. We do the same analysis for price floors. I'm not going to go through it in anywhere near as much detail because it's the same analysis, really. But for price floors at this price floor level, we have excess supply. So we're going to trade this amount QF. When we have a price floor, we trade this amount QF. Because while there's lots of supply, there's lots of people wanting to try and sell you goods at this price floor, there's no one willing to buy the goods. There's not the demand. If we're thinking about this as the labour market, we can say that there's lots. This is going to be unemployment. This excess supply will be unemployment, basically. So we see excess supply. And we can talk about what happens to consumer surplus, producer surplus. Again, the distinction here is that now price has increased while quantity has fallen. That means producers are unclear what will happen for producers. Maybe they'll become better off, but maybe they'll become worse off. They really like the fact that they're getting to charge a higher price, but that means they have to sell less goods, so potentially they're worse off. They might be better off, they might be worse off. Consumers are definitely worse off because they're charging a higher price and they're getting less stuff. So they're just definitely worse off, no questions. But in any case, total surplus definitely falls because the total surplus is now this trapezoid here, which means our deadweight loss is this triangle in here of deadweight loss, surplus that could have existed but doesn't because of this price floor. Now, this is price floors for standard type of objects. In our nice toy market, where we have things like equal bargaining power, where we have things like where we care equally about consumers and producers, which we mostly do, but there are certain circumstances where we might not. I'm not at all trying to argue whether minimum wages are good or bad. This sort of really super toy analysis suggests that minimum wages are bad because it creates unemployment and it creates lower surplus, total surplus in the economy. But more developed analyses can go either way, right? Just because this super duper simple analysis, if we talk about this for minimum wages, this is not the best model of the labour market. This is just a super straightforward, simple model. I'm not trying to argue whether minimum wages are good or bad. There is conflicting literature on the quality, on the effectiveness of minimum wages to treat whatever they're trying to treat, usually poverty. There's conflicting studies. There's a general consensus, but there are conflicting studies. Okay, questions, concerns on price? Yes, so in every case that'll fall. Yes, questions, concerns on price ceilings, price floors? Yes. I extraordinarily encourage you not to try to remember things in that way. So the question was, is the deadweight loss always in the such and such and such and such? And the answer is, don't try and think of it that way. Because, first of all, the answer is no. Deadweight loss is not always in this area. In this particular location, it is in these two examples because we have under consumption, because we consume too little. If we have overconsumption, things go differently. If we have world markets, when we have trade in second semester, things will look in second term, things will look very different. Don't try and memorize this is the triangle that is the deadweight loss triangle. It's just not a good way of thinking about these problems. You want to be thinking about this problem as what is the total surplus now? What is the total surplus in equilibrium? What is the thing that is different between those two outcomes? What is the difference between total surplus now and total surplus in equilibrium? In both of these cases, it is these regions because in both price ceilings and price floors, we get underconsumption. But in other cases, that won't be true. So subsidies, it won't be true. And as I say, in second term, when we talk about trade, it absolutely won't be true. It can be on the right of this, it can be underneath, it can be above, it can be in all sorts of weird places. As I say, there'll be a lovely example which we'll cover in week 12, just to give you a quick flavour of something from week 12. There'll be a nice example in week 12 where we talk about world price, autarky price, some price that we try and charge in the market, and we'll end up with something like deadweight loss in these regions here. Right? It will depend on the particular market, is what I really want to emphasize. Yes? No. So the question was, can we compare price ceilings and floors as being better or worse? The way I've drawn these graphs is designed that the ceiling and floor look like they're about equally bad. Again, in terms of deadweight loss, the price doesn't matter, only the quantity traded matters. Both price ceilings and price floors can cause the same change in quantity traded, potentially. They'll just have different prices that do that. Right? Price ceilings cause falls in quantity traded because there's not enough supply, because the price is too low, so there's insufficient supply. Price floors cause reduction in quantity traded because the price is too high, and so there's not enough demand. When the price goes up, quantity supplied goes higher, but quantity demanded goes down. So quantity traded, if there's no confounding variables, quantity traded will fall if the price goes up above the equilibrium level. Whether the floor or ceilings have higher impact on quantity traded will depend on the particular nature of the demand and supply curves. It'll depend on the sensitivity of the demand and supply curves in particular. If you have if you have a near vertical supply curve, then price, if you have a vertical supply curve or nearly vertical supply curve, then a price ceiling will have very little impact on quantity traded. Right? If you have a nearly vertical demand curve, then a price floor will have very little impact on quantity traded. But it will depend, right? Which one will have a stronger effect, I guess, will depend. Okay. Final questions on price ceilings and floors? Yes, sure. So the question was about examples. Examples are good, and we do want examples in lots of places. Public transport is usually subsidised, not price floored. A price floor would be something more like, I could be wrong about how this works, but if you look at public transport in Tokyo is mostly privately owned. The subways are all privately owned. I imagine, though I could be wrong, well, one way the government could intervene there to reduce prices is by putting in a price ceiling. The government could just step in and say, there's a price ceiling, you can't charge more than so much. In Australia, for our public transport networks, they're mostly government-owned and they're mostly subsidised rather than price floored and price ceiling, which we'll come to right now. So they're subsidised so in most cases, we have subsidies rather than ceilings and floors. Subsidies and taxes rather than price ceilings and floors. But you could certainly introduce a price ceiling or a price floor on public transport, but you wouldn't. You want to encourage people to use it, and so you tend to do subsidies instead. Price floors and ceilings always reduce consumption. There are price ceilings on toll roads in Australia. So toll roads so the government steps in and says the toll road cannot charge more than a certain amount. And that's just a strict price ceiling. Okay, taxes. So the other method that governments use to intervene in the market, they use price floors and ceilings sometimes, but much more often what we talk about are taxes. And so we talk about excise taxes. So these are different from, example, income taxes, which are levied on your income. This is an excise tax, so they're levied on goods and services. So it's a tax levied by the government on a good or service. The way we're going to talk about taxes and subsidies, particularly taxes here, is that there's a gap between the price that buyers pay and the price that sellers receive. So rather than when I go and I buy an apple, I pay $2 per kilo, 20 cents of that goes to the government. So while I pay $2 per kilo, or $4 per kilo, let's say, while I pay $4 per kilo, the seller only receives $3.50 per kilo, or whatever it is. This is how we're going to model taxation. We're going to model them as this gap between the price that buyers pay and the price that sellers receive. And we see this here. The price that buyers pay exceeds the price that sellers receive by this amount T, the amount of the tax for per unit taxes. We're mostly going to use, for our analysis, we're going to use per unit taxes because they're easier and because they are essentially the same. All the qualitative results all flow through the same way. So there's per unit taxes, which are just fixed amounts you get charged extra. In Australia, cigarette taxes are per unit taxes. So the government steps in and says, for each cigarette packet, we're going to charge you $15 of tax. Roughly, I think it's about that much. It might be $10. I could be wrong. $10 to $15 of tax. They don't step in and say, we're going to charge you 50% tax. Right? They say $10 per packet. Petrol taxes are per unit taxes. It's so much per litre. Most what we call sin taxes, so that's cigarettes, booze, I guess cigarettes and alcohol being the main ones. What other sin taxes are there? No? Cigarettes, alcohol, and petrol to a lesser extent. Most of these come through as per unit taxes. And as I say, we're going to be doing things as per unit taxes because qualitatively they're the same as ad valorem taxes, but they're easier to model. The other option is ad valorem taxes. This is where the government steps in, as I say, and says you have to charge 10%. Right? We're going to take 10% of what you charge as taxation. So the price buyers pay and the price sellers receive differs by a percentage. So the GST, so the goods and services tax here, and most countries have some kind of value-added tax. These are these ad valorem. Ad valorem means by the value. So most real-world taxes are ad valorem, but to keep our lives easy, we're going to use per-unit taxes. So taxes can be levied on producers or on consumers. The impact, what we call the impact of the tax, is whichever group gets formally charged the tax, right? Whether it's the producers or the consumers that are formally charged the tax level. However, and this is what our modelling is really trying to emphasise, is it doesn't really matter who faces the impact of a tax. It doesn't actually matter who faces this impact. When you buy a banh mi from the shop in town, who here feels like they are impacted? Who here feels like they pay GST when they pay, not that GST is charged, but that they pay GST when they buy fast food? Some, a couple, good. I'm glad that failed horribly last time I used that example. I would say I don't feel like I personally pay GST. I feel like I look at the price that I get charged and I pay whatever the price says on the board. And that the company pays GST. I understand that the company pays GST, but I don't feel like I do. Technically, I pay the GST. Technically, when you buy stuff, you are the one paying GST, according to the legal definitions and the impact of the tax. But I want to emphasise it doesn't really matter. It doesn't matter who formally pays the tax, because what matters is the impact of that, is what actually happens, is the incidence, what actually happens with that tax. All that the tax really does is produces a gap between the price buyers pay and the price sellers receive. It doesn't really matter who in principle is paying the tax. It's still a gap between the price buyers really pay and the price sellers really receive. So, the tax gap. So we have our marginal benefit curve, marginal cost curve. These are demand and supplies. In equilibrium, we live at this nice equilibrium point here, P star, Q star. And we can charge a tax gap. The government steps in and they charge a tax, a value-added tax of size T. And so we just plop down this tax of size T here, which is going to be our gap between the price buyers pay and the price sellers receive. So this is going to be what we end up with as the price buyers pay and price sellers receive and quantity traded when we have this size of taxation T. We have this size of tax T, this size of per unit tax. And we see that price buyers pay and price sellers receive differs by the tax level, and that the quantity demanded is the same as quantity supplied. It's just that the price being paid is different. So our market is still in some kind of equilibrium. It's just not in the market equilibrium. It's in the equilibrium with a tax applied. So this is how we're going to model taxation, as by putting in this tax wedge. This is why it's called a wedge, because it makes this little wedge here between demand and supply. Any questions on this and how this was done? Hopefully it's not too bad, but I'm happy to take questions. Okay. Now the benefit of this, from my perspective, is that we get really nice welfare analysis. And so, yes. The market equilibrium is still at this point here. Market equilibrium. The tax doesn't affect the market equilibrium, but the tax will affect the observed outcome, I guess you might call it, or the equilibrium with taxation. So this is, market equilibrium without tax. You would still call this you wouldn't call this the equilibrium quantity. You'd call this the quantity traded under this taxation scheme, or something. Yeah. So it's still an equilibrium outcome in some sense, in that when you have this tax, if we trade this quantity and we charge these prices, then the market isn't in shortage, isn't in surplus. So it is an equilibrium in some sense, but it's not the market equilibrium. It's not the P star, Q star market equilibrium. Questions, concerns, otherwise? Okay. So by introducing a tax gap, the quantity sold in the market falls. Fell from the equilibrium outcome to this tax level quantity. The price buyers pay rose, right? The price buyers pay went from P star up to PB. The price sellers received fell. It fell from this nice P star down to PS, the price sellers receive. And the gap in the small e equilibrium outcome, in the tax equilibrium outcome, is the gap is equal to the tax level. Right? This is what gives us the market not being in shortage or in surplus. And so that's it. That's the tax gap. In the textbook, they use a different method for modelling taxation. In the textbook, they use this alternative method, which is just we increase costs by shifting the supply curve, or we decrease benefits by shifting the demand curve. They're fine. They're fine ways to model taxation. If you prefer them, you can use them. You will not be penalised in marks. They're fine ways. They produce equivalent results. But, as I want to emphasise, they make welfare analysis more difficult, and they obfuscate the distinction between impact and what we will talk about shortly of incidence of tax. So they make it hard to tell the difference between impact versus incidence. So I don't like this way of doing it, but it's the way that's done in the textbook, and if you do it in exams and do it correctly in exams, then that's fine. So, welfare analysis. In our nice market equilibrium, we have consumer surplus given by the big dark triangle and producer surplus by the big blue triangle. When we introduce our tax, consumers and producers both become worse off because they trade less, the price buyers pay goes up. Both of those things are bad for consumers. They trade less and the price sellers receive goes down. Both of those are bad for sellers. And so both our consumers become worse off because they pay a higher price and they buy less goods. Producers become worse off because they receive a lower price and they buy less goods. But we are missing something on this graph. What we're missing is government revenue. Because with this so far, because in addition to producer surplus and consumer surplus, the government's also taking in tax. And they're still a part of the society, right? They're still a part of the economy as a whole. So we do want to include government revenue as part of our welfare analysis. Can anyone hazard a guess at where on this graph I might draw government taxation? Government tax receipts? In the middle? I mean, that's right, so yes. This is going to be the square in the middle. And the reason it's the square in the middle, can you tell me why it's the square in the middle? Because the only one left. It's not a great answer. That's okay. It's because when I want to talk about how much revenue the government raises T dollars per unit, right? Total government revenue. Government raises T tax revenue per unit sold times the number of units sold. Right? We multiply the amount per unit times the number of units, and that's just this box here, right? The tax per unit times the number of units graphically is this little box here, as we would expect. So this is our total tax. Sorry, yes. So this is our total amount of taxation. Tax take. And this is government revenue, right? This is additional surplus, right? Because this is government revenue. It has been paid by someone. It's either been paid by consumers or producers, depending on who pays the impact of the tax. But it's government revenue. We do still have deadweight loss because we're trading at an amount that is not the market equilibrium outcome. So we still have our deadweight loss, right? So this taxation does cause deadweight loss here. It's an inevitable outcome of most forms of taxation, except ones we'll talk about at the end of today. Taxation causes deadweight loss. It's not always bad, but it almost always causes deadweight loss. The reason why we still might want to do taxation is because even if we look at a larger scale question, as in this basically says the government should never tax anything, right? Is the short answer from this, which is obviously false, right? And so then the question becomes, why might the government, given this result, given that tax causes deadweight loss in most cases, at least in this case, why does the government cause taxation? Why does the government do taxation? The first reason we'll talk about, which is Pigouvian taxation, is related to externalities. That's an important reason to do taxation. The second reason to do taxation, second main reason why the government needs to charge taxation, is that in this market, the government's caused deadweight loss by doing taxation. Right? No question. In this market, deadweight loss has appeared. But the government is able to spend money in other areas on public goods, for example, which we won't talk about, or on common resources, which we won't talk about, or on just goods generally, which cause more benefit that you can get otherwise. So when the government might tax your production or might tax you for, say, the GST, they charge you GST, but then they give you healthcare. And then while charging GST causes deadweight loss in the Apple market, providing healthcare causes massive, massive gains in a different market. And so the reason you do taxation is, yes, you accept that there will be deadweight loss, which is a bad thing, except for externalities and Pigouvian taxation. You accept that there's going to be deadweight loss, but you say we can take this tax and we can use it elsewhere to do really good things. We can use it elsewhere to produce more surplus than will be produced by the market outcome in places like education, healthcare, public transport. Because within this market, it's still welfare analysis. Well, I mean, it's always called welfare analysis, because within this market, it's still welfare analysis. Within this market, it's welfare analysis. So surplus is welfare. Consumer surplus is how happy I am as a consumer. Producer surplus is how happy I am as a producer. Taxes, how happy I am as a government. This is why we call this welfare. Sorry, so welfare here meaning welfare in the sense of how well off I am, not welfare in the sense of the dole or Centrelink. I see, I got you. No, the welfare part of this is how happy people are. How happy the government is, how happy, yeah. It's welfare in that sense. That's right. Yes? No, the total surplus is smaller. Total surplus has fallen by the amount of deadweight loss. If the quantity was, well, the quantity wouldn't already be at QT. The quantity would be at the equilibrium outcome, unless we had some reason to think that it wouldn't be, unless we had something affecting the market to make it be not in equilibrium, then it's going to be in equilibrium. Right now we live here. After we include the tax, the market doesn't live at a particular. We no longer can talk about the market living at a particular point on this curve, because the price buyers pay and the price sellers receive is different because of this taxation. So we have this quantity traded, but the prices for buyers and sellers are different. Yep. So it's deadweight loss in this market, but the fact that we then have taxation revenue, we can then use that in other markets. Whereas the other one, with price ceilings and price floors, you can't do that because all of the surplus is still held by consumers or producers in that market. Yeah, exactly. We're reducing the amount, but we're getting we're reducing the amount of total surplus out there, but we're getting some of it to go to the government, and the government, under certain circumstances, can use it more effectively. Pardon? The green part is part of, well, I wouldn't say that. The green part's part of total surplus in this market, because it's still government revenue. The reason why we might do this, when it looks terrible, is that in practice you can take this bit of taxation, this green box, and make it bigger by applying it in markets which are more effective. Okay, I want to push on and talk about, quite a few things. Okay, so welfare analysis, quick summary. You know what, we've done the summary. Deadweight loss, the cost to society as a whole is deadweight loss. Again, taxes do not directly affect deadweight loss because they're a price issue, but they do indirectly cause deadweight loss because we change quantity traded. One of the things this means is that if we target taxes in specific types of markets, we might be able to end up with lots of government revenue and very little deadweight loss. And in particular, if we target our taxation in markets with really low price sensitivity, we can get lots of government revenue, very low deadweight loss. This is not entirely true. You really want to have low elasticity, but we'll talk about that. We haven't talked about that yet. So, high sensitivity, low sensitivity market. We have a market with high sensitivity, really nice flat demand supply curves. Taxation per unit causes massive changes in quantity, compared to low sensitivity outcomes where changes in price cause relatively low changes in quantity. Huge, same size tax, exactly the same size tax here, right? Same equilibrium price, same size tax, massive changes in deadweight loss. Massive differences, I should say, in deadweight loss between these two markets. The reason why there's these massive differences is because in this nice low sensitivity market, we introduce this tax and it has relatively little effect on the amount that's actually traded in our market, because the price doesn't really matter that much for both consumers and producers. So yes, they charge higher prices. Yeah, we consume a bit less, but not noticeably less. Right? This is our cigarette markets. Right? Cigarettes have beautiful low sensitivity, low price elasticity, and so we can charge taxation and have relatively little. If we charge taxation, we have relatively little change in quantity, which means we have relatively little deadweight loss. High sensitivity markets, we want to try and avoid charging too much taxation. This is a slightly trickier argument that I'm going to make right now, but I'm going to run with it anyway. This is part of why why the push so Australia in 2001, I think, no, 1999, went from very, very different tax schedules on all sorts of goods and services to a GST, so a fixed 10% on all goods and services, or almost all goods and services. That's really nice because with a 10% on everything, on every goods and service you provide, it's more or less equal here, whereas a lot of, no, it's too hard. It's too hard. Ignore me. We want to try and avoid taxing high sensitivity outcomes, high sensitivity objects, because you get lots of deadweight loss, and we don't like deadweight loss when we charge high sensitivity, when we charge taxation in high sensitivity outcomes. So this is just a way to target our taxation to try to make ourselves as well off as possible. So taxing markets with we want to tax markets with low price sensitivity. Questions, concerns, quickly? A bit behind. Okay. I talked about incidence of tax very briefly. So we can talk about impact of tax as who formally pays. I hate the way these words are arranged. These words definitely should be the other way around, but it is what it is. The impact of tax is who formally, officially, legally pays the tax. The incidence of tax is the group which actually suffers the detriment from that tax existing, or suffers the majority of the detriment of that tax existing. So I can talk about relative sensitivity. I can have a market with sensitive producers here, nice flat supply curve. I can have a market with sensitive consumers, nice flat demand curve. And I can introduce taxation into these markets, and I can plot the same size tax in these two markets. Right? The way this is set up is the deadweight loss in these markets are the same, but the incidence of tax in these markets is very different. Who is most negatively affected is very different. Right? There's a lot of lines that pop up very quickly here, but it's just equilibrium price, price buyers pay, price sellers receive, equilibrium quantity, quantity with taxation. And I can talk about the change in surplus for my various groups, for my consumers and my producers. Right? This is the change in consumer surplus. Right? As we see here, the change in consumer surplus, because consumers go from getting this big triangle in equilibrium to this smaller triangle with the tax, and so they lose this area that's marked in black when we have sensitive producers. Here we have sensitive consumers, and so our consumers lose this area in black. We see a massive difference here. So the incidence of tax depends on who is more sensitive, and we see the same thing for producers, right? Here the incidence falls almost entirely on producers. Incidence falls very, very little on producers. So for different markets which look similar in many ways, but are different markets, introducing a tax might really heavily affect consumers, might really heavily affect producers. It's hard to say. The way you would work this out is you would look at the sensitivity of demand and supply, or the elasticity of demand and supply to work this out. Notably, the incidence tends to be held by the relatively insensitive person, right? By the low sensitivity group, whatever it happens to be. So you talk about, say, cigarettes. Cigarettes have super vertical demand curves, right? But not necessarily that vertical supply curves, because for cigarettes, the price doesn't really matter. You're addicted to cigarettes, you have them because you're addicted. However much they cost, you pay what they cost. You pay the price, whatever the price is. The price goes up, you pay a higher price. The price goes down, you still smoke a pack a day. You just pay a lower price. So we have a pretty vertical demand curve for cigarettes. So we're in this kind of world. What that means is taxation is borne mostly by consumers. Right? Taxation here is borne mostly by consumers, in the sense that consumers are the ones that become worse off. The cigarette companies become a bit worse off, but not significantly. They become a bit worse off because a bit less is bought and the price they receive is a little bit lower. But basically the government goes, we're changing tax from $10 to $15, and the cigarette company says, right, well then we're going to increase, so that's $5 extra tax. Then the cigarette companies go and they say, well, we're going to increase our prices, our posted prices by $4.50. So we'll take 50 cents less extra per packet, but we'll charge you $4.50 extra per packet. So there is still, it's still like the taxation, but it's not that big a deal. Questions, concerns? All right. Nope, no summaries. Subsidies. Subsidies work the same way as taxes, but they mean the opposite thing. They mean that the price buyers pay is less than the price sellers receive. So we talk about public transport. Public transport in Australia is pretty heavily subsidised, in that the price, that when I buy a train ticket in Sydney or a bus ticket, let's say I buy a bus ticket in Canberra, I pay $1 and the bus company receives $2. Because the government steps in and says, for every person who rides your bus, we're going to give you $1. This still has deadweight loss in our economy, in our market, but it has deadweight loss from overconsumption. So we can do all the previous analysis. We can do all these relative sensitivity analysis. We can do everything in this case of subsidies. I would encourage you, I'm not going to go through all of them today, but I would encourage you to go and do those analyses for subsidies as well. So the difference here, we have our normal market equilibrium. When we introduce our subsidy wedge goes over here. It goes over here because we want the difference between the price sellers receive and the price buyers pay to be the size of the subsidy, but the price sellers receive will now be higher than the price buyers pay because we're subsidising consumption of this good. And so then we talk about welfare analysis. Welfare analysis for overconsumption is a little bit trickier. It's a little bit uglier because you have to keep track of a few more things, but it's the same basic principle. In equilibrium, we have this much total surplus from consumers and producers. Now we have masses of consumer surplus because buyers are paying a really low price and consuming a massive amount of goods. So consumers are super happy. Producers are super happy because they're being paid a really high price for their goods and they're selling tons of it. What have I not included yet in this welfare analysis? Pardon? I haven't put in deadweight loss yet, but there's another aspect I haven't included. Last time for the taxes I had producer, consumers, and government. The government, I have to talk about what happens to the government here. And the government here is paying out a subsidy, right? So it's losing revenue, right? We're not getting revenue in now, we're losing revenue, we're paying out an amount of subsidy. And the amount as before is the subsidy per unit times the amount actually traded. So this is the size of the total subsidy actually being paid out, right? It's the size of the subsidy times the amount actually traded. And this is all bad, right? This is negative government surplus. This is negative government welfare because the government is paying out all of this money. So we have this much plus this much minus this much, which takes a little bit of working through. Right? It's not super straightforward to work this through, but this little triangle up here is just consumer surplus and nothing else. This little triangle down here is just producer surplus and nothing else. This weird little pentagonal region in here is consumer surplus and producer surplus, so it gets counted up twice, but it's also paid out by the government, so it also gets negatived in terms of total subsidy. Total subsidy is negative surplus. That's why it's in red. And because it's the government paying out subsidies, right? The government is losing this money. This little triangle up here, it's producer surplus, right? It's producer surplus, but it's also subsidy, so it gets cancelled out. This little triangle down here is consumer surplus, but it's also subsidy, so it gets cancelled out. This triangle over on the right here, this is just subsidy. This is just money that the government is paying out, which is not surplus to anyone. And so this is my deadweight loss. Because my surplus is this area here minus this little triangle that's left over. And so my deadweight loss is then just the little triangle. It's a matter of working through it gradually. I do not, again, I strongly encourage you not to try to do things like memorize this. It's just a bad idea. And it means, and I've seen all sorts of weird things people drawing down on diagrams that make absolutely no sense whatsoever because they've tried to memorize it. Or because they've gone, it's one of the triangles that's somewhere around. And I don't want you to think of it that way. I want you to think of it as, well, what's the producer surplus? What's the consumer surplus? What's the total surplus that we get in our economy, in our market? How does that compare to the equilibrium total surplus? The difference is deadweight loss. The other way you can work through it is really just to think about total surplus and ignore what's consumer and what's producer. The fact that I'm over-consuming here means that this is going to be my deadweight loss, right? Because for the same reason it was way back here, is that if I'm consuming out at this level QS, that I'm over-consuming at QS, and so every unit after the equilibrium quantity is causing deadweight loss. It's making my market worse off. Any questions? Questions, concerns, problems? Yep. Yeah. So the little triangles, the questions about this little triangle here and this little triangle here, and the rough reason why is this is the total the ideal total surplus. This little triangle up here, let's say this little triangle down here is positive consumer surplus, but it's also subsidy. So it cancels. This little triangle here is producer surplus, but it's also subsidy. So it cancels. This little triangle here on the right doesn't cancel. It's just negative. It's just being paid out in subsidy that's not being benefit to anyone. So it's the deadweight loss. You can have a look at summaries in your own time. Question? Questions? Concerns? Issues? It's getting interesting. Okay, I have 22 minutes to talk about probably the most important thing that we're going to cover in this entire course, which is externalities. So, an economic activity. So an externality is a byproduct of economic activity. So an economic activity produces an externality when that economic activity has some effect, either positive or negative, on some additional person. So it's a spillover effect. It's we make a trade, I'm one party to that trade, you're one party to that trade, but because of the trade that we make, person over there also gets affected somehow for any sorts of reasons. We divide our externalities into positive externalities, which is when that other person over there becomes better off, and there's lots of things like that. Education is a standard example of this. When you have a more educated society, even people who did not receive the education become better off for various reasons. Vaccinations are a really, really simple and straightforward example of this. When I get my vaccinations, other people also benefit because of herd immunity. Things, and even really simple things like if I clean my yard and make a nice looking front yard, other people benefit because when they walk past, they're walking past a nice looking front yard, right? They have no part in the decision on whether I clean my yard or not, but they benefit from the fact that I've chosen to do that. We can talk about negative externalities. This is when the bystander does not benefit, this bystander is harmed. So this is standard things like pollution. If I am an energy producer and I produce coal, then other people who live nearby my coal plant are negatively affected by my coal plant. They don't have a say. They're not a consumer of my coal or of my electricity necessarily, let's say. They're not a producer, because I'm the producer, but they're still affected by the trade, the fact that I've chosen to make and sell coal power because of pollution. Road congestion, when I drive on the road, then the congestion causes negative externalities to other people on the road, and again, an especially messy front yard. It does the same thing, but in reverse to an especially nice looking front yard. So externalities are when two people engage in trade or when trade occurs and other people are also affected. And it's the effect on the other people that is the externality. Any questions, concerns, problems? Lovely. So supply curve is marginal cost, demand curve is marginal benefit. Market outcomes where marginal benefit equals marginal cost. However, these are the private marginal cost, the private marginal benefit and cost to the people engaging in the trade. But with externalities, there are other people who are also affected. So the market outcome is where so if we talk about negative externalities now, the market outcome is where marginal benefit equals private marginal cost. But in our markets with externalities, there's additional costs. Quantity price. What about marginal benefit? What about private marginal cost? So the market outcome is still here. However, for each unit that we consume, there's an additional public cost, and we call that public cost the marginal external cost. So the marginal external cost is the cost to the bystander of that final unit of production, that next unit of production. So in addition to the private marginal cost, there is also a marginal external cost, and so we can talk about the social marginal cost. So the social marginal cost is the cost to society. So that includes both the private marginal cost to the actual producer and also the marginal external cost, the cost to bystanders. And so in addition to the private marginal cost, we also have a social marginal cost. We also have the social marginal cost. And the gap between these two things, the gap here, is the marginal external cost. The gap between these is the marginal external cost. And now we have a problem. Now we have a problem with our nice story about markets leading to efficient outcomes, about market equilibrium being efficient outcomes, because the market equilibrium is this point here. Right? Point A, let's say. But this is overconsumption. Right? From a societal standpoint, this is overconsumption. Because if we compare the marginal benefit to society with the marginal cost of society, you'll notice that at our level of consumption, let's call it QM for market, at our market level of consumption, we're consuming at a point where the social marginal cost is non-trivially higher than the social marginal benefit, which is also just the marginal benefit. And so we're over-consuming compared to the social optimum. So, market transaction does not take into account the marginal external cost, normally, which means that the unregulated market results in overconsumption. And overconsumption, as we talked about, leads to deadweight loss. So this externality, this negative externality, is causing us, it means that our market outcome is no longer the socially optimal outcome. It means that with our negative externality, we are over-consuming and therefore getting deadweight loss. This is a kind of market failure. And so we can talk about government intervention that might try to solve this market failure. And there's various types of government intervention that might solve this market failure, which is to say that we are currently consuming at A, which is bad. The market naturally consumes at A, which we think is bad because we're over-consuming, because the social marginal cost exceeds the marginal cost to society exceeds the marginal benefit to society of that last unit of production. We'd really like to be consuming at point B. I'm going to call this Q star. We'd really like to be up at point B where the cost to society is the same as the benefit to society, or the marginal cost of the last unit produced to society is the same as the marginal benefit. And so we want to think about government intervention that might be able to rectify, that might be able to move us from A to B. But before we do that, let's talk a little bit about positive externalities. They work very similarly. They work very, very similarly. In exactly the same way, or in a very similar way anyway, we can talk about the private marginal benefit. And the marginal cost of production. But for positive externalities, there's additional benefit floating out there to third parties. Right? When additional consumption happens, when additional trade happens, other people become better off. When we have more vaccinations, it's not just the people getting vaccinated that are better off, it's also the wider society. And so we can talk about we talk about the gap opening up between the private marginal benefit and the social marginal benefit. And again, this gap is the marginal external benefit, is the gap between these two things. Is the gap between the social marginal benefit and the private marginal benefit. And we have the exact same problem, is that in our unregulated market, when we don't do anything in this market, in an unregulated market, we consume at this point QM, for the market quantity, but this is bad. Right? This is bad because at this market quantity, the social marginal benefit of the last unit produced is a lot larger than the marginal cost to society. So we really want to produce more stuff. We want to trade more, produce and trade more. We really want to live up here at point B, where the marginal benefit to society is the same as the marginal cost to society for the last unit produced. And we can become better off if we do that. So, market transaction does not take into account the marginal external benefit, so the unregulated market results in underconsumption. Underconsumption leads to deadweight loss, and this is again a market failure. And so we want to intervene in our market to encourage people to use this good. And there's lots of reasons why we might want to. So the public transport example that was brought up earlier, we want to push people towards using more public transport, and subsidies are a way we're going to do that. We want to push people towards using more public transport because when people use public transport, we get social benefits. We get less people using cars, which means there's less congestion on the roads to other people who remain on the roads. There's less pollution in the air, in the sense of, cars produce pollution. We get less noise pollution in the air in the sense that cars are noisy. So we get lots of nice additional benefits to the people who aren't actually going on the train, aren't actually using public transport, because there's lower congestion, there's lower pollution for everyone. For everyone else, I should say. I should say very, very quickly, both of these cases cause the market outcome causes deadweight loss. Why? Well, because again, we have deadweight loss due to overconsumption, which is going to end up being this region here with some work. We have deadweight loss due to underconsumption, which is going to be this region here, again, with a little bit of work. We could be at B and getting all this nice massive region here, but instead in the market we live at A and we only get this region here. I will do a quick analysis actually. A single, very quick analysis here. Colors. When we're at A, if we actually live at A, if our market lives at A, then we get producer surplus, right? The gap between the price they receive and the marginal cost, we get consumer surplus, the gap between private marginal benefit and the price we pay. And then this area up here, this other area that we still do get, is the external benefit. Right, this space up here is going to be our nice external benefit. This is our benefit to other people. Why is this the external benefit? Because the gap here is the marginal benefit. And so when we produce the first good, we get this much marginal benefit. When we produce the second good, we got this much extra benefit. For the third good, we got this much extra benefit, and so on. So this is going to be our external benefit. This is the extra benefit to society because of our production. That's not taken into account by the market. And so we could be at B getting all this, but we're at A instead, we're only getting this much, and so that means the deadweight loss is the area marked in red. This little triangle in here marked in red. Similarly, I'll leave that. And you can do the same argument for I just want to leave this on the board, that's all. So you can do the same argument for negative externalities. There's a producer surplus, there's a consumer surplus, there's a cost to society, which is going to cancel out a lot of your producer surplus. So are externalities bad? So both positive and negative externalities cause deadweight loss. Positive externalities increase total welfare. So positive externalities are not bad. It's not like we want to suppress positive externalities because they do increase total welfare. Negative externalities are just purely bad. They reduce total welfare. They cause deadweight loss. Negative externalities are terrible. Positive externalities are a bit of a mixed bag, right? They do increase total welfare, but if there is a positive externality, then we are under-consuming the good. Then the market outcome results in under-consumption. Right? It's a positive externality, the market consumes at QM, we could do better by consuming at Q star. So in both cases, we can do better than the unregulated market. We can have the government step in and do stuff to push us back towards the socially optimum level, which is now not the market equilibrium. So there's a simple solution. The simple solution is the command and control solution. These are policies or regulations that directly restrict or increase the level of production or require the use of certain technologies. This is where the government steps in and says, right, in this market, in the electricity market, you must produce this much power, or you must use this kind of power line, or you must do X, Y, and Z. Sorry. Or you must do X, Y, and Z. Quite a lot of particularly air and water regulations behave like this. It's where the government steps in and says, drinking water must look like this. Right? Water that comes out of taps has to have this quality. The level of air quality in your city must be at least this high. And you just have to do that. There are some issues with this. The one issue is that they tend, particularly if they simply state the technology, if the government steps in for, say, water, keeping us for, say, water quality assurances, if they make a water quality assurance by stepping in and saying you must run your water through this filter and then through this type of thing and then this filter and then it can go into the water supply. This has a problem in that there's no incentive for firms to find cheaper ways to do this. Right? It's much better off for water just to say your water has to be at least this clean, and then whoever's providing water can figure out the best way to do that. It's also a little bit tricky because if you're in this kind of world and you just declare, or let's say actually this is a better kind of world. If you're in this kind of world and you just declare that Q star is the most you can produce, right? The social optimum is the most you can produce of this good that has negative externality. It's hard to decide who gets to produce that because there's incentives to change it. There's lots of pushback from producers who want to produce more and from consumers who want to consume more. No one wins, right? No one feels like no one who's being directly affected is happy, right? You introduce this command and control which says Q star is maximum you can produce. Consumers are worse off, producers are worse off. No one's happy. The society's happy, but none of the actual people are happy. So politically it's difficult. For that reason, command and control tends in a lot of cases to have fallen out of use. It's still common, but it's fallen out of use. compared to what it used to. What we tend to use now are what we call market-based approaches. And so we can talk about a market-based approach, the most common of which is the Pigouvian tax. This is named after the particular guy, Pigou, and is a Pigouvian tax. It's a tax designed to induce agents who produce negative externalities to reduce the quantity produced so that it goes back to the socially optimum level. I'm going to use a new graph for this. To get the quantity produced down to the socially optimum level. So again, we have a negative externality. Negative externality, cost is different. Without intervention, we live here at point A. We want to change our consumption. We want to introduce a tax to push the amount traded back down to Q star. We want to introduce some sort of tax to push our amount traded back down to Q star. If anyone hazard a guess at what size per unit tax we would charge to try to push our amount traded back down to Q star? The top of my long dotted line. I believe that's right. Assuming that you mean this bit here? Yes, perfect. If I charge this level of taxation, then the market naturally will end up where I want it, producing the amount that I want it to produce. I just charge this taxation, and then I get exactly what I've talked about before. I get the price buyers pay being high, the price sellers receive being low, and the quantity traded is now at this lower level, but now we're trading at the socially optimum quantity. So we're implementing a tax, and that tax pushes production down, or pushes the amount traded down, but now it's, instead of pushing it down away from the social optimum, we're pushing towards the social optimum. So we can introduce, if we apply an appropriate size tax, we could end up with the socially optimum level of output. This is the argument for, carbon taxes are the standard one. This is the standard argument for carbon taxes. The standard argument for taxing anything that has a negative externality is this argument. We can introduce a tax and make society, I should say, better off by doing so, because we get rid of that deadweight loss. We can do the exact same thing for subsidies. I'm not going through it. We can do the exact same thing for subsidies, so we can introduce a subsidy on markets with social marginal benefit. We'll go through it very quickly. Social marginal benefit, external. It's been a long 2 hours. For markets with a marginal external benefit, for markets with a positive externality, the market lives at A. The market lives at A. The market produces this amount, Q market. We really want to trade this amount Q star. That's going to be that's the socially optimum level, is Q star. And so we need to introduce an appropriately sized subsidy to make that happen. And so the subsidy that we're going to have to introduce is going to be the per unit subsidy. This is going to be the size of my per unit subsidy. When I introduce that subsidy, my market naturally extends out, the market naturally grows to the social optimum level, and we get more total surplus. Producer surplus increases, consumer surplus increases, government tax revenue goes down a lot, but the key difference here between subsidies with and without externalities is now there's an external benefit that's also growing, because the external benefit is also growing as we have more people using, let's say, public transport. So we want to encourage that, to get as much of that external benefit as we can. To internalize the externality is the phrase that's used. Questions on Pigouvian taxation? We're still using, so demand is private marginal benefit. You can't
can't see that. Demand is more like private marginal benefit. Supply is private marginal cost. Because as a consumer, I only care about myself. I don't care about the fact that when I have a nice-looking yard, other people are better off. I care about the fact that I like having a nice-looking yard. When I'm a producer, I don't care about the fact that other people are affected by the pollution from my coal plant. I care about the fact that I get money from selling coal and get surplus from selling coal power. Not necessarily, no.